For today's lesson and the final lesson of the chapter, we're going to be discussing the converse, the inverse, and the contrapositive, as well as introducing the biconditional. Let's get started. To begin with, we want to remind you of what the conditional statement is. So the conditional statement states that if P, then Q, and it's represented symbolically by the single arrow, P then Q. The conditional statement helps us set up the converse, the contrapositive, and the inverse because they're all related back to the statement. Let's take a look at those three statements. So there are three different variants of the conditional statement, and they are the converse, which is Q arrow P, the contrapositive, which is the negation of Q arrow the negation of P, and finally the inverse, which is the negation of P arrow the negation of Q. Now it's important to note here that these three statements are not logically equivalent to the conditional. They're not the same as it. They don't have the same truth values. They're just ways that we can take the conditional statement and rearrange them, and they have specific names. So again, just to kind of remind you, for a conditional statement, that is something that is P arrow Q. And if we compare that to the converse, we have just switched the two. So they've traded places. For the contrapositive, you're going to switch the two and negate them. And then for the inverse, just negate the two statements. Let's go ahead and apply these logical variants. For our example here, we have two statements, P and Q, where P is gotta catch them all, and Q is gotta catch all the logical variants. We're going to help Ash defeat the nations and write the following compound propositions. So we're going to write the conditional, the converse, the contrapositive, and the inverse. So we can see that for the conditional statement, it would be if you gotta catch them all, then you gotta catch all the logical variants. We're now going to take this statement and use it to create our converse, contrapositive, and inverse by using the appropriate strategies. For the converse, we need to flip the two statements. And what we get for a converse is a statement, if you gotta catch all logical variants, then you gotta catch them all. So again, you can see we've switched the two halves of our statement to create the converse. For the contrapositive, we need to switch them and negate them. Looking at our contrapositive, we have if you don't gotta catch all logical variants, then you don't gotta catch them all. So again, the difference here is we are switching our two statements and negating them. And then finally, we have the inverse. So for our inverse, we just negate the original statement, and we would say that if you don't gotta catch them all, then you don't gotta catch all the logical variants. For one more example of using these logical variants, we have Ash, who just captured all the logical variants, and then he runs into Aladdin. And Aladdin has the following statements. P would be, Genie, I use my last wish, and Q would be, I wish for the logical variants. So for a conditional statement, Aladdin would say, if I use my last wish, then I wish for logical variants. For the converse, we're going to take these two statements and switch them. So we get, if I wish for the logical variants, then I use my last wish. For the contrapositive, we would switch them and negate them. So if I don't wish for logical variants, then I don't wish or use my last wish. And then finally for the inverse, you would say if I don't wish for logical variants, then I don't use my last wish. Okay, and now for our final logical connector, we have the biconditional. So the biconditional is something of the form P if and only if. And we're going to focus on really this kind of language in between the two. So if you see if and only if between two statements, it's a biconditional, and it is a double arrow. Now we're going to talk a little about in class how that is different than the tautology symbol, but if you have the double arrow, then we have a biconditional. An example of a statement here would be the stock market will go up if and only if interest rates decrease. So we have stock markets and interest rates. Those are our P and our Q statements. So since we have the if and only if in between, I know I have a double arrow. Stock markets are going up. That's a positive. Interest rates are decreasing. That's a negative. So you have to put negation of Q, and that would be our symbolic statement. Let's go ahead and look at the truth table for the biconditional. So the truth table for the biconditional is similar in a way to the exclusive disjunction. Just kind of the opposite thought here. The conditional statement, or so the biconditional statement, is going to be true as long as they are the same. So if both sides of the statement are true, or if both sides of the statement are false, then the biconditional is going to be true. It's going to be false when the two statements are opposites. So it's kind of the inverse of the exclusive disjunction. Let's go ahead and apply this to some truth tables. Alright, so for our truth table, again, we're always going to start the same way. True, true, false, false, true, false, true, false. Moving forward for the negation of P, it's the opposite of our P column, so we're going to change that to be false, false, true, true. As we move forward to do the conjunction, again, the conjunction is only true if both sides are true. And we're going to be looking at these two columns. So the only time that both P and Q are true is for that first row there. So we have true, false, false, false. And then finally, when we do our biconditional, we're trying to find where both symbols are the same. And we are looking at these two columns. So if we draw a double arrow in here, are they the same? Nope, so that's false. Are they the same here? Yes, so that's true. Are they the same here? Nope, that is false. And are they the same here? No, so one more time, that's false. So again, the only time that our statement is going to be true is when both sides are the same, and it only happens in our second row here. Alright, we have one more example here, and in this example we again have three propositions like we did in the last section. So when we have three statements, P, Q, and R, half of the column is going to be true, and half the column is going to be false. Then for Q, we're going to alternate by twos. So 2 trues, 2 false, 2 true, 2 false. And then finally for R, it's every other one. So true, false, true, false, true, false, true, false. This is always the way we're going to start when you have a P, a Q, and an R. As we move forward to do our inclusive disjunction, we're going to be comparing P or Q. And that is true as long as one of those columns has a true in it. And that's going to happen in each row until we get to our last two rows. So we can see down here that we have both falses for our P and a Q statement. So these are both going to be false. When we do our negation of P, we're going to change it. So instead of the first half being true and the second half being false, we have the first half is false and the second half is true. And we do our next conjunction. We have R and negation of P. So I'm looking at R and negation of P, and that's only going to be true when both of those are true. So we have true and false, and then false and false, true and false, false and false, true and true is a true statement, false and true, and then false and true. So again, I was looking at these two columns, and the only time that they are true, or both true, happened in this row. Oh, and in this row as well. Nope, this one should be false. Okay, for our final statement, we are going to be comparing two separate rows, or sorry, columns. So we have these two columns using our biconditional statement. It's only going to be true when they are the same. So here we see they're opposite, so that's false. That's false. That's false. That's false. Here we can see they're both true, so it's true. They're opposites again, so we have false. These are opposites, so we have false. And for our last row, they're both false, so that is again a true statement. Okay, that completes our notes for this chapter. You guys will be applying this homework tomorrow in class.